As you can see from the title of this video, this tutorial is about molar mass and doing mole conversions. Okay, two different topics, and we'll solve them two different ways, but what you're going to find out is that many times to do mole conversions, you are going to have to calculate the molar mass of an element. A few handouts that may go with this that help you out if you weren't here today, right, is if you go into the Chapter 3 handout section, right, you'll print one out that saying Avogadro number and molar mass, and then the second one that has the questions on it are simply conversions, that handout. If we're going to talk about finding molar mass and doing mole conversions, a couple things you need to understand. Right? The first thing is that there is something called Avogadro's number. Avogadro's number tells us the number of particles in 1 mole of a substance. And if you remember from when we did our units of conversion way back in Chapter 2, you'll remember that mole was the way we measure amounts of things in chemistry. So Avogadro's number is this. It says that there are 6.022 times 10 to the 23rd atoms or molecules of a substance in 1 mole. And that's what you need to understand about Avogadro's number. It doesn't matter what element I'm working with. If I have 6.022 times 10 to the 23rd atoms of it, we say we have 1 mole of that element. If I have 6.022 times 10 to the 23rd of something that's not an element but a compound, like carbon dioxide, we don't say that we have atoms of the compounds, we have molecules of it. But we'll use them interchangeably because you're going to find that molecules to moles is the same conversion as atoms to moles. So, a lot of times as part of doing conversions, you are going to have to find the molar mass of a substance. And how we get the molar mass is by using the periodic table. And what you do to find the molar mass is you simply take the number of atoms in the formula times the mass off the table and then add them together. So you list each element find the mass off of the periodic table, multiply the mass by the number of atoms, and then add them all together. First example would say something like, what is the molar mass of NO2? Find the molar mass of NO2. If I'm going to do this, try to follow these steps. List each element separately. So if I look up here, it looks like I have nitrogen and oxygen. 2. Find the mass off of the periodic table. If you find nitrogen on the periodic table, its decimal number is 14.01. Oxygen's is 16.00. Little rule that's kind of an unwritten rule. Anytime you pull a number off of the periodic table, we will always round it 2 places past the decimal. Some numbers are already expressed that way. Some numbers you will have to round. For instance, oxygen on the table is 15.999. I'm going to round that to 16.00. But for sig figs, we will always go 2 places past the decimal on every number from the periodic table. Step 3, multiply the mass by the number of atoms. So, for nitrogen, in my formula, there's a subscript that's not written there of 1 after nitrogen, so it's just a 1. And for oxygen, there's a subscript of 2, which means we multiply it by 2. So we'll take 14.01 times 1, which, no surprise, is 14.01. 2 times 16 is going to be 32.00. And then to get our molar mass, right, we will add those together, which looks like we are going to get a mass of 46.01. And then the units on molar mass are always grams per mole. And that is what allows us to use them in conversions. Right? Because it's grams per 1 mole, we're allowed to put those things in brackets together as we go through. And the big thing I wanted you to remember is molar mass calculations always 2 past the decimal. So anytime you get the number from the periodic table and you add them up, they will always go 2 places past the decimal. Let's try another one that's a little bit more complicated. How about something like H2S6. H2S6. Going to try to do the same thing. List the elements we have first. Looks like I have hydrogen and I have sulfur. Then what I'll do, right, is find the masses of each. Hydrogen is the one exception to the 2 places past the decimal rule. Hydrogen is the only element on the periodic table we will list 3 places past. So we will list it as 1.008, not 1.01 or 1.0. Times how many hydrogens there are, which looks like there's 2. Then do the same thing for sulfur. Sulfur's number off the table is 32.07 times the number of sulfurs, which is 6. And then we'll get numbers for each of those. And so hydrogen, 2 times 1.008 is going to be 2.016 plus 6 times the 32.07 is going to get us 192.42. And notice, we can still say everything off the table is 2 past, right? Because anytime you have something with hydrogen that isn't hydrogen, it's always going to limit us to 2 places past. So we take our 192.42 plus 2.016, and listing that 2 places past means we would say 194.4, and then 2 places past, 3.6 is going to be 4.4 grams per mole. And most often, what you're going to do is use this as part of a conversion problem. Very rarely will I simply just ask you to find this, and you won't have to show me this work. Once you get well versed in how to get this number, you can just solve it, get the number in your calculator, and plug it. But early on, when we're doing worksheets for the first time, I will have you show me this work, and once I see that you understand what you're doing, we'll phase that out, and you'll go to the more streamlined, faster version. So let's transition this into conversions. The good thing about conversions is that you already know how to do these. We've learned how to do conversions. You did it when we were back in chapter 2 with all the things of converting meters to nanometers and kilograms to grams and centimeters to millimeters and things like that. The steps stay the same. The only difference is instead of having a separate sheet that we used to have to find our conversion factor, we won't use that anymore. We will use the periodic table because that is what tells us about relationships of elements and compounds. So a little refresher on our steps to converting. Right? Remember, when we do conversions, right, step 1, take number given over 1. Step 2, unit to eliminate on bottom. Step 3, desired unit on top. If possible. And just like we had 1-step and 2-step and 3-step conversions when we did them before, the same holds true when we're converting grams to moles and things of that nature. Step 4, find correct conversion factor. And step 5, do math / sig figs. So there are our 4 or 5 steps to conversions, right? And now let's take a look at what some simple conversions will look like for grams to moles. So on the second sheet that you are hopefully looking at, you will see that example 3 now says how many moles are there in 7.64 grams of helium. Just like we did before, we will have to pull this question out of words, right, that would lead us to something that looks like this. 7.64 grams He equals question mark moles. From here, right, we try to follow our steps. Take the number given over 1. 7.64 grams He over 1. I just want listed. Step 2. Draw my brackets, unit to eliminate on the bottom. Here are my brackets. I am trying to get rid of grams, so grams He go on the bottom. Step 3, desired unit on top if possible. So I'll put moles He on top, and then I ask myself, is there a relationship between grams and moles somewhere? And the answer to that question is yes. Grams to moles of an element I can always get from the periodic table. Right, so it's okay to put those in there. Right? Now it's just listing what it is. Anytime we do a gram to mole conversion, you will always put 1 with moles. To find the grams, you look up to the periodic table. I would find He off the table, and I would take it 2 places past, which means I'm going to list it as 4.00 grams of He. Now, that was my correct conversion factor, so I plug that in. Do the math and do your sig figs. So, grams of helium will cancel, leaving me with moles, which is what I wanted. And now remember, if it's on top, you multiply. If it's on the bottom, you divide. So 7.64 divided by 4.00 looks like I get a number in my calc of 1.91. Then we have to check our sig figs. Remember, when we multiply and divide, we care about numbers of sig figs, not places past the decimal. The 1 will never limit you, right? But the periodic table will, as will the number at the beginning. So 7.64 has 3 sig figs, 4.00 has 3, so we can have 3 in our answer. 1.91 has 3, so that answer is good just the way it is written. Example 4 on that paper says, how many grams of carbon are there in 7.49 moles of it? So this time we'll try to write a question again. List what you know, which is I have 7.49 moles of carbon, and list what you're trying to find. I'm looking for question mark grams of carbon. Try to follow the same steps. Start with the number you're given, 7.49 mole of carbon over 1, which we won't list. Draw my brackets. Unit to eliminate on the bottom is going to be moles of carbon. Thing I'm trying to find is grams of carbon, and then we decide, do we know a relationship between them? always know grams to moles, right? We'll get it from the table. So we can leave this as a one step. Notice the 1 doesn't always go on top. 1 will always follow mole. So we will put a 1 with mole, and to get the grams of carbon for here, I will go to the periodic table and pull the decimal number from the box next to carbon. If I look up off the table, sure enough, carbon is 12.01. Now that everything is set up, it's all about doing units, sig figs, and the math. So moles of carbon cancels, leaving me with grams of carbon. I have to do the math, so I take my calculator out, 7.49 times 12.01. I get 89.9549. And now we have to check our sig figs. I have 3 here, 4 here. That doesn't hurt, so I get 3 in my answer. So there are more than 3. So does an 8 count? Yes. Does a 9? Yes. Does a 5? Yes. Right, there are my 3. Now I have to round. 5 has a 9 after it. Will the 9 round the 5 up? Right, you bet it will. So that will give us an answer of 89.6 grams of carbon. Just double checking my math. Oh, that's what? I forgot a number. Okay, so the number in my calc was actually 89.9549. So does an 8 count? Yes. Does a 9 count? Yes. Does a 9 count? Yes. Now, there's a 5 after, and remember the rule of 5. If there's something after, it rounds up, which makes this 90, but we need to have 3 sig figs, so I have to call it 90.0. Right? My apologies about that. Right? Simple one-step conversions using the table. Let's take a look at some that are a little bit more complicated, things that involve compounds or possibly multiple steps. Okay. Example 5 says, how many atoms of sulfur are there in 1.25 grams of sulfur? So I know I have 1.25 grams of sulfur, and I want to know about question mark atoms of sulfur. So we try to follow our steps. Start with we're given over 1. 1.25 grams of S. I draw my brackets. Unit to eliminate on the bottom is grams of sulfur. What I'm trying to find on top, it would be atoms of sulfur. Do I know a conversion between those? I do not. Right? Can't do grams to atoms in one step. So what we do is we try to find something that relates to both. From the last examples, we know grams can relate to moles. And from the very beginning of this, we have a relationship between atoms and moles. So we are going to try to do this in 2 steps. So we can't go from grams directly to atoms. So we will go from grams to moles, and then we try again. Moles of sulfur on the bottom, atoms on top, and I always know a relationship between atoms and moles. So now we plug our numbers in. Remember, anytime you see moles, it's going to be a 1. Moles to grams, we get off the periodic table. So if I look up sulfur off of the table, you will see that it is 32.07 grams. Moles to atoms, we also always know, right? It is Avogadro's number, so I'm going to put 6.022 times 10 to the 23rd in for the top. Last but not least, we just have to do our math and watch our units and sig figs. Grams cancel, moles cancel, leaving me with atoms. Now we do the math. 1.25 times 6.022, and remember, 10 to the 23rd, hit second, your button above the 7, and an E pops up, and then 23. So my calc says 1.25 times 6.022 E 23, and then divided by the 32.07. My calculator says 2.34720923 times 10 to the 22nd. And don't forget that exponent. People will say, is it important? And the answer is yes. Right? Think of it in money. You could either have $2.34, but times 10 to the 22nd means I move this decimal 22 places to the right, which would be about $2 trillion. I'll take the 2 trillion. Right, so sig figs to finish out, 3 here, 4 here, 4 here. So we get 3, 2, yes, 3, yes, 4, yes. Will the 7 round the 4 up? Yes, it will. So we get 2.35 times 10 to the 22nd atoms. So it's a two-step problem. Right? If you can't get directly there, I usually will say get to moles as quickly as you can, and then try to get it to the unit that you want. One more example. Example 6 says, how many grams are there in 12.5 moles of Li2O? So I have 12.5 mole Li2O, and I want to know, question mark, grams. Li2O. So, first time we have done a conversion like this with a compound. So how do things change? All right, the good news is they don't. Right? We still follow our steps. Take the number I'm given with its unit over 1. I draw my brackets. Unit to eliminate goes on the bottom, which would be moles Li2O. What I'm trying to find on top, which is grams Li2O. Do we know moles to grams? You bet. Right? It'll be a little more complicated than just pulling a number off of the table this time, right? But we still always know grams to moles. So, moles still always gets a 1, but now, to get myself grams of Li2O, I have to do what we did at the beginning, which was this. We have to break Li2O down and then add them up, because remember, this was grams per mole. So I'll do that down here. I know I have Li, I know I have O. I list its mass. Li's mass is 6.94 times how many there are, and there's a 2. Oxygen's mass, 16.00 off the table, and there's one of those. So the bottom one, 16.00, and then the top one, 2 times, right, 6.94, right, 7 doubled would be 14, so we're going to be 0.12 less than that. So it looks like it's going to be 13.88, but double check in your calc, that's why you have it. Add that to your 16. Right, looks like you get 29.88 grams per mole. And that is why I'm able to plug the 29.88 in per grams over 1 mole. So 29.88. From here out, it's just finishing the math problem. Moles cancels, leaving me with grams Li2O. And we take our 12.5 times 29.88. I get 373.5. And we watch our sig figs. 3 here, 4 here means 3 in my answer. Yes, yes, yes. Right? First number after is a 5, so we check. Is there anything after it? No, which means this has to round to an even number. If it's even, it stays the same. If it's odd, it rounds up. So we would say we have 374 grams of Li2O. One more example. Sorry, I forgot there were 7, not 6. All right, so if you take a look at the last one says, how many molecules are there in 154.8 grams of CaCO3? So if we're trying to write our question, right, list down what you know. Looks like we know that we've got 54.8 grams CaCO3, and I'm looking for question mark molecules CaCO3. Do not abbreviate the word molecule, because if you do, inevitably what is going to happen is you're going to abbreviate it MOLE, mole, or MOL, mole, which is something totally different. Moles and molecules are two very different things. So you have to write it out the whole way. Other than that, this problem will be pretty similar to everything else we did. Start with what you're given. 54.8 grams CaCO3 over 1. Draw your brackets. Unit to eliminate on the bottom. Grams CaCO3. Put what you're trying to find on top, which would be molecules. We don't know a conversion from grams to molecules. What we do know is a conversion from grams to moles. Then we would try again. Okay? What am I trying to get rid of now? Trying to get rid of moles, so it goes on the bottom. And I'm trying to find molecules. This time I can put it in there because I always know atoms to moles and molecules to moles. Now it's about filling in what we know. Moles always gets a 1, so we put 1s there. Grams to moles we always get from the periodic table. Right? And this time I won't draw all that work out. Right? I'll show you what it's like when you do it just in your calculator. I have 1 Ca, so I go to the table, I pull Ca's number, which is 40.08. Plus, I have 1 carbon. Carbon is 12.01. Plus, I have 3 oxygens, so I'll have to add 3 times 16 into that, which is 48, which gets me a number for this of 100.09. Right? And what I was doing there was what we did right here, right? But you don't have to show that work as we go through. So long as you get to the right number, you can do it all in your calc. Moles to molecules is always Avogadro's number, 6.022 times 10 to the 23rd. Now it's just a matter of finishing the problem. Grams cancels, moles cancels. I'm left with molecules, CaCO3, and we take our 54.8 divided by 100.09 times 6.022 second E23. Right? My calc says 3.297088 times 10 to the 23rd. And watch our sig figs. 3 here, 5 here, 4 here. Means we get 3, so 3 yes, 2 yes, 9 yes. Will the 7 round the 9 up? You bet. Which is going to make us have 3.30 times 10 to the 23rd. And so all 1-step and 2-step conversions. Right, I hope this helped you out. Right, if you're having any questions, feel free to walk through it again. A lot of times, the second time you see it, right, it's less overwhelming. Or stop in for some help. I'd be more than happy to assist.